Okay, who thinks who thinks they know the answer to this? Yes. Man, that was an impressive answer. That's exactly right. Well, the point was more to get you thinking about it, not to necessarily know how to do it. You're going to think today's lesson is awesomely easy since you seem to nail that answer with such ease. Okay, let's talk about what's happening here. If I were to FOIL that out, I would get x squared minus 2x minus 8. Okay? If I asked you to graph that, you could, by the things we've done so far. And you would graph it like this, hopefully. You'd get your y-intercept as negative 8. You'd find your two zeros, which are kind of given to you in the problem, 4 and negative 2. You'd say, oh, my end behavior is positive, positive. And you'd graph it like that. Now, what is the question asking? It's asking, where is this function greater than 0? On a graph, what that means is, where is it above the x-axis? Everything less than negative 2, and everything greater than positive 4. You nailed it. Now let's think about this. Of a polynomial, something without a denominator, something that's fluid, remember something never has a break or anything, the only way that a polynomial can go from positive to negative, in other words, make this wrong or right, the only time it would switch from being wrong to right is where it crosses, or where the function equals 0. And that's how it ties into the entire rest of the chapter. What have we been doing all chapter? Finding where functions equal 0. So that's what we're going to do today. We're going to find those values. Now this one was, you can just pull it straight out, 4, negative 2. You find those values, and then you set up a number line. Here's how you're going to do them all day. Yes, it is. You're going to set up a number line like this. Now, every number that you find makes the function equal to 0. So in this case, that was negative 2, positive 4. Those are the two places it could cross where it will equal 0. So you need to check their intervals. You need to check some number over here, some number in here, and some number over here to see which of those intervals make it positive. Because you're not going to have the graph in front of you. So, like, let's try negative 3. That's something less than negative 2. Something to the left of negative 2. Whoa. Stop it. So you plug in negative 3. You get negative 7 times negative 1, which is positive 7. Positive 7 is greater than 0. Is this a true statement? Yes. Check. Then you try a number between these two, like 0. So that'd be negative 4. Come on. You've been pissing me off today so bad, you have no idea. Fight me. Negative 4, positive 2. Plug those in. You get negative 8. Is negative 8, come on, you little piece of garbage, greater than 0? No, it's not. X.
Right, negative 4 isn't the same negative 4.
No, I didn't. I plugged in 0. When I plugged in 0, I got negative 4 and positive 2, which multiplied to get negative 8. Okay, so now I try a number greater than 4, like 5. That'd be 1 times 7, positive 7. That is greater than 0. Check mark. Hence where his answer came from. This is from negative infinity up until negative 2, and from 4 to infinity. Very impressive answer, sir. And that's what you're going to need to be doing all day. And that is the only thing we're doing today. We're just going to have different kinds of problems that we do it with. It doesn't. It doesn't. The only thing that even has a curveball later, and not really even a curveball, is just the different ways you can write it on the number line. But everything else is the same.
Is this where you have like
Yeah, at times. Yeah. Let me ask you this. When you're doing a domain, how do you know whether it has a parentheses or a bracket on the end? This is an important question. Yes, all that's true, but when it comes to right, essentially, here's the universal way. If you can plug in that number, like negative 2, if you can plug that into the equation and get a true statement, it's a bracket. If it's a false statement, It's a parentheses. So, if I plug negative 2 into here, it says 0 is greater than 0. Is that true? No. Hence the parentheses. Now, if this had been an equal sign, 0 is equal to 0, and it would be a bracket.
So it's like a this included.
Exactly. Exactly. Think. I think that's everything for the DOM. Okay. Oh, I'm already recording. Good reminder, Mr. Crawford. Okay. Now, this is the only one all day that you're going to have a visual aid, but I think it's best to start with this question, even though you can see it comes to the very end, because it helps us visualize what's happening. It says, here's a function. Now, if you get something today where they're on different sides, just move it all to one side. Subtract the 7x, subtract the 6, you end up with this. 2x cubed plus 11x squared minus 7x minus 6, and now it's just greater than or equal to 0. It's easiest if you do it like that, because if you're looking at 0, then you can just look at, is it above or below the axis? That's why we're going to stick to that all day. So, where is this thing greater than 0? Just looking at it. Somebody raise your hand and tell me, just by looking at it, other than go, let's see, obviously not this. Where is that thing greater than 0? Josh, left. 1. To infinity, right? From 1 to infinity, it's greater than 0. Where else? So what? About negative 1/2? You're right, and that's the answer. That's visually what it'll look like. This one was greater than or equal to 0 between negative 6 and negative 1/2, brackets or parentheses? Brackets. It has an equal sign. And then from 1 to infinity, bracket, parentheses. That just means and, like this is included. If it's an equal sign. The more universal way to remember it is brackets if it's true, parentheses if it's false. The reason I'm trying to keep you away from just looking for the equal sign is because when you get to problems like, oops, wrong direction. We're going to come back. These are actually, when you get to problems like these, well, you know what? Let's not get ahead of ourselves. I'll talk about that in a minute. Okay, we already did number 1. Number 11 looks a little different. It's not factored for us, so I can choose any way I want to find the zeros of that function. What way strikes your fancy? Quadratic equation. Sounds good to me. Or you could factor, or you could do the p's over q's, find one, divide it out, whatever you want to do. Quadratic. Negative b plus or minus square root of b squared minus 4ac all over 2a. So that's negative 10 plus or minus, I believe that's 196 over 6. I only know these numbers off the top of my head because I just did it. 14, that's right. It's 14, no, thank you. Okay, negative 10 plus 14 is 4. 4 over 6 is 2/3. Negative 10 minus 14, bless you, is negative 24 over 6, which is negative 4. So there are my two roots. Those are the two numbers in which I need to test around. So let's do it. So negative 4, 2/3. What's the number less than negative 4? Just anyone. Negative 5. Okay, negative. We plug in negative 5. You get 75 minus 50 minus 8. It's a positive number. Is a positive number less than 0? No, x. Less than negative 4. What's the number between these two? 0 is a nice choice whenever it's available. Plug that in. 0 plus 0 minus 8, negative number. Is a negative number less than 0? Yes, it is. Number greater than 2/3. 1's a nice one. That gives me 3 plus 10 minus 8. That's 13 minus 8, which is 5. Is 5 less than 0? No. Come on. Please don't do this. Alright, so that is an x. So your answer would be -4 2/3 only, brackets or parentheses? Brackets. It had an equal sign. And see if it's true. That's right. 17 is not less than 0, so it's false.
Okay. So this is sort of been like, if negative 5 would work, it would be like -2.
Well, I'm glad you asked. I'm glad you asked. Let's think about this. If I asked you to graph that again, you could. Y-intercept, find your roots, in behavior, graph. I know at both of these roots, if you were to graph it, you would have, say, it crosses here, and goes on, right? Everywhere it crosses, it has to go from positive to negative or negative to positive. It has to. That's what it means to cross. So, how does that help you? When you're working today, when you get your answers, you should never have back-to-back checks or X's. It should always alternate. What scenario, now think about this, what scenario algebraically would cause us to have back-to-back checks or X's, meaning that it touches but doesn't cross? That's right. If you have a double root or anything that occurs an even number of times, that means it's going to touch, right? Which would make it either check or XX, depending on what the question was asking. Let's look at number 9. I think that's an example of that. Number 9. If you factor number 9, I'm just going to factor that one, although you could have used any method you wanted to. Notice you get 3 twice. So there's only one number around which you need to check. You can use context clues from how you know to graph to make this easier on yourself. I know whatever I get here, I'm also going to get here. Why? Because it's a double. It's going, like if there's my axis, it's going to go like that. It's not going to cross. So I plug in, what, -4? Or 0 would be even easier. Let's try 0. Why did I choose -4? Let's try 0. 0 minus 0 plus 9. Is 9 greater than 0? No. Greater than 0. I'm sorry. You were right. I said it wrong. Is it less than 0? No. Okay. Let's pick a number greater than 3. Now we know this should be an x. Let's try 5. 25 minus 30 is -5. A -5 plus 9 is +4. Is 4 less than 0? No. So nothing works. This has no answer. None. But again, we knew it was going to be back-to-back because it was a double root. Just a little, you don't have to use that knowledge today, but I can't tell you how many people last block with our questions were all the same thing. Is this right? You can look at the question and be like, oh, you should have 2 answers. Anything that has a square should have 2 answers. There weren't double roots, and yet they still had like XX check. So I immediately knew, no, that can't be right. Because nothing's going to cause it to repeat itself because you didn't have a double root or anything. Yeah.
So what are the
Yep.
So the fact that where it does check, you usually back.
Either XX check.
Yeah.
If we had another one, yeah. Everything with a check you would include.
-3, check, you do -3.
Yep. Even if this had said equals, then it would just be 3 because it does equal 0 here, but it doesn't.
Well, how do you do this?
Sure. Like number 11. You mean like that? You mean one where you have no solution but it says equal? I don't know. Problems like this, all you have to do is subtract everything over to one side first. And it doesn't even matter which way you go. As long as you leave your inequality the same, it doesn't matter. You'll get 10 done.
So if you had done the quadratic function on and not the
You'd still gotten 3 twice. Because your determinant would have been 0. Questions on that one?
and then
You try it number before or after 3. Yeah. Alrighty. So, you're looking for all the numbers that could make this a true statement. That one has no end. There's nothing you can plug into that where that would be true. That's right, yeah. No. Today you should get nothing more. You might get something that's ugly. Like, I would take them as decimals if you get something ugly, because if you have 1.725, that's not really a big deal, because you get to choose the numbers you check. So you just try 1 and 2. So, yeah. If you might get ugly numbers, but you won't get imaginary today. If you did get imaginary, well, let's think about, but if you actually got an imaginary, that means it doesn't actually cross at all. So I guess that would be another scenario where you'd have check, check, or XX. Thanks for bringing that up. I forgot about that. Imaginary roots, should you find some, and I guess it's possible, means it doesn't cross at all. So there is a chance that, yeah. No. 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 He was saying, think about this scenario. Let's say, here's what he asked. He said, what if you have, a graph that looks like this, and the function said something, f of x, blah, 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 is less than 0. Well, this whole thing is less than 0. It has 2 imaginary roots. So you'd still need to check it, but this would also give you a check, check, because they're both below the axis. Okay. So that would cause you to have back-to-back. All right, this one the exact same way. Everybody tends to look at 33 and think that one's harder. It's really not. What's going to make this part equal 0? 2, and it's occurring twice. So 2, 2, and 7 over 2. Now, you should know when you check this one, not necessarily. We don't know that yet. It could be check, check, x. But you do know these two are going to be the same because it touches, and this one will be different. You do know that. So once you know one, you actually know all of them. What's an easy number to plug into this? 0 is always good. 2 minus 0 is 2. 2 squared is 4. 0 minus this is negative 3 halves. Come on, stop it. So that'll give you a negative 3 1/2. Positive times negative is negative. Is negative less than 0? Yes. What did I plug in? 0. So I know these are going to be the same, and that this one has to be different. So I can immediately conclude that you can do that till the cows come home as long as you know what you're doing and you're right. Don't get cocky and think you know and just be guessing though. I don't really care how you write your answer, but I think what Mary Kate was asking earlier was on the test, there could be any number of ways it could be written. This one might be written negative infinity to 3.5, parentheses, parentheses. Or it could be like this. Here's how it could be on the test. That's a number line implying everything less than 3 1/2. Yeah. They won't cross today. Yes. Either one of you, I don't really care. What did you get? Oh! Joseph, you should teach this class. You're right. He's right. This does not have an equal sign. So 2 is not included. Which means this would actually go negative infinity to 2, and then 2 to 3 1/2. Wicked smart that kid is. Wicked smart. Kudos. I just nothing. I was just complimenting him. 2 cannot be. If you plug in 2, is it true? You would get 0 times something, so 0, and that would say 0 is less than 0. Not true, so you can't include it. Good eye, sir. Yes, sir. You can't choose 2 because you know that equals 0. Yeah. 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 35 through 41, same thing, except you might have to do some factoring. If you don't like to factor, then you can P over Q, take one out by finding it, synthetic division. You want to try one like that? Let's do one like that. All of these, every single one of these factors, like neatly. But if you're not a factorer, that's cool. Let's practice the skills we learned earlier in this chapter. Skills. Yes. You're right. The POs over Qs would be plus or minus 1, 2, and 4. So we're looking for one that works. Let's try -1. It'd be -1 plus 1 minus 4 plus 4. What do you do? -1 works. So let's take it out. Now I can also go ahead and write that up here. -1 works. That's one of my things I need to check. Take it out. 1, 1, 4, 4. 1, -1, 0, 0, 4, -4. Sure enough, it did work. That leaves you with x squared plus 4. Ooh, ooh, ooh. We're going to have imaginary. I'm glad this happened. I didn't know this did happen. So, this is going to give you, if you just set it equal to 0 and solve, x plus or minus, or it's essentially plus or minus 2i if you solved it. So, the only thing you really need to check is the -1, because these aren't going to cross, so nothing's going to change. And then from here, it's just the interval check, just like we've been doing. So there you go. Yes, you will get imaginary, and you won't need to check it. The only thing you would need to check is if the only thing you got was imaginary, that means it never crosses. So you just need to try any point at all and see where it is and see if the whole thing's true or false. If it never crosses, it can't change, so just check anything. It does, but here's what that implies. Like this supposedly would cross 3 times, right? But if you were to graph it, only one of them was real, and it was -1, and the other 2 are imaginary, so it's going to look something like this. So there's only one time that it changes, which is why it's the only thing you need to check. Well, if they're not there, then they don't affect your graph, hence the imaginary part. Why they exist? Well, because here's the reason. If you look at this, the person who's trained to think in these ways would say, oh, this is going to cross the axis 3 times. How do you explain why it doesn't cross the axis 3 times? That's why you need imaginary. That's right. There actually is did you know, I don't want to get off topic, but there actually is an imaginary number, like part of the number on the, it actually comes out 3-dimensionally right at you. It just never comes into play in this class. Yeah, yeah, like you know how you have your x-axis, your y-axis. The imaginary number axis actually comes straight at you right out of the origin. It's just you never really need that, except unless you go to like get your doctorate. So I had to do a presentation on it once. It was kind of cool. Anyway, well, we need to check something. Let's try 0. That'd be 0 plus 0 plus 4 plus 4 is 8. Is 8 greater than 0? Yes. So it's going to be check, check. No equal sign. So it'll be -infinity to -1 and -1 to infinity. I like the thinking going on, all these outside the box questions. Alrighty. Only other thing we're going to do today, what if it wasn't a polynomial function? What did we talk about yesterday that would also cause your function to potentially go from positive to negative without crossing? How can it go from positive to negative without actually crossing the axis? An asymptote, right, or basically a break in the graph. What gives you vertical asymptotes? Anybody remember that from yesterday? Something in the denominator that equals 0. That's right. So that's just going to be the other things you need to check. It doesn't change what we're doing. It's just something else you need to check. So here, what's going to make the function 0? 4. You need to check that. But also, what's going to give us an asymptote? -3. So that's another number I need to check. So on this one, I would check -3 and +4. Good one. Oh, you mean with a bracket? No. Good question. No vertical asymptote number will ever give a bracket because it can't possibly do that. Okay. Let's do a harder one. Yikes, none of these get that bad, do they? 53. Okay. 53. Now, One thing about the ones that have vertical asymptotes is, you know how the other ones we could say we could logic our way to, if you know one, you can kind of know the rest of them? It's not the case with vertical asymptotes. They could jump from here to here. They could both stay positive. Whenever you're going around a vertical asymptote that you're checking, all bets are off. It could be checks, they could be x's, they could be one of each. You just don't know. So you're going to have to actually check all your intervals. Okay, 53. What's going to make the thing equal to 0? I'm going to put -2 here so that I remember these two are going to be brackets because they can equal 0. This one will be a parentheses because it can't, because it's in the bottom, which is a no-no. So from here, it's just like the other ones. Set up your number line. -4, -2, 1. Check your intervals. -5. You plug in -5, you get -1, -6, -3. That'll be +6 over -3, which is -2. Is -2 less than or equal to 0? Yes. Check. Now I'll try, what's the number between -2 and -4? -3 sounds good to me. That'll give us +1, +4, -1. Oh, the phone. Shouldn't happen. Negative. Thank you. Okay. So, -4 over -1 is positive. Is 4 less than or equal to 0? No. Now we need to try this interval. 0 seems to be a good one. 4 times -1 is -4. -4 over 2 is -2. Is that less than or equal to 0? Yes. Now, was this a root or was this a asymptote? I mean, just the 1. It was a root. So we can go back to using logic if we wanted to. I know these have to alternate. But again, you can just check it too. Let's try +2. That's 6 times 1 over 4. So that's 3/2. Is 3/2 less than 0? No. So your intervals would be -infinity to -4 with a bracket. -2 to 1, parentheses, bracket. Again, parentheses because it was an asymptote. Touche. And there you go. Yes, sir. Yes. Yeah. You're basically evaluating the function at that value. 57 and 59 and 55. The only thing that make those potentially different is, in the past, I said just subtract the number over, right? And everything was hunky dory, happy with the Lord, right? Because it just added into your polynomial equation. Now, if you subtract over 3, it kind of changes things. Because now, -4, like let's look at 57. -4 is no longer a 0. Because it's not being compared to 0, it's being compared to 3. And if we subtracted that over and plugged in -4, you would just get 0 minus 3, and it's no longer the 0 of the function. So, whenever you have one like this with a denominator, it's probably easiest in that one scenario if you just solve it the way it is. Don't really set it equal to 0. For instance, let's look at one. I'm done with that talking. Let's throw that up. All right, let's look at 55. First things first. Where am I going to have an asymptote? -3. That won't change. But now, I'm no longer looking for what makes this equal to 0, because 0 is not the number I'm interested in. So what you want to do is just solve it. You can use an equal sign. Solve it. Find where this is going to be true. X plus 1 equals 2x plus 6. Subtract, subtract. So -5 is where this function is going to equal. And you can plug that back in if you want to check it. And let's see. -5. That gives me -4 over -2, which is 2. And sure enough, that is, that's where they're the same, just like if they were zeros. So we were right. So -5 is the other thing we need to check. I just multiplied this over. I'm literally just solving for x. Yeah, then
On top,
I'm sorry?
we set the top equal to the bottom sign.
Nope. I basically made this into an equal sign and just found where is this going to be true. So I just solved it. I set it up just as a regular problem, multiplied this over, so that was 2 times x plus 3, hence the 2x plus 6.
Okay.
Yeah, then I subtracted x, subtracted 5, 6. I apologize.
You would still have to know the number 30.
Yeah, well that's just because the asymptote won't change. That still can't happen. So, it all sounded bad, but you're right back to where we were. You still have numbers you need to check, and you still have an original equation you need to plug it into. So, make yourself an underline. That'll be -3, -5. And just remember, just plug them into the equation. Let's try 0. 0. Touche. Whoa. Come on, Ben. Thank you. You were right. I was wrong. Alright, let's try Huh? I have no problem saying I was wrong. How dare you. Okay, so let's pick a number less than -5. -6. So that'll give us -5 over -3, which is positive 5/3. It's 5/3 less than 2. Yes. Check. Let's try a number between these two. -4. That'll give me, I'll do it down here. -3 over -1, that's positive 3. Is 3 less than 2? No. Let's try a number over here, like 0. That'll be 1/3. Is 1/3 less than 2? Yes. Now you're right back to doing your intervals. And I still had to find, imagine this. No, don't imagine this. Yes, yes. But both having parentheses, no equal sign. Yes. Alright, imagine this was a 0 right here. Okay? Now, what am I looking for? I'm looking for where it's below the axis, right? So, that would be -1 and -3, right? Well, just because it's a 2, think about it like this. Now I'm no longer looking where it's below the axis. Now I'm kind of looking where it's below the line y equals 2. So it's the same thing. I still have to find where it touches. So I still need to find where these equal. So that's why I literally solved it for where it equals 2.
So you have x plus 1 and 5 equals 2x plus 6, and then equals 6.
Yeah, you're finding what x value is going to make them equal and therefore be a crossing point, just like the last one. Yeah. Yeah. And the next two will work the exact same way. Negative infinity to -5, and then -3 to infinity. Because there's no equal sign. Yeah. If there's no 0 in the end, then just solve for x and that'll end your vertical asymptotes. Yeah. Good questions. Very good questions. Any other questions? Sure. 57. Now, darn it, there's a number, so I can't just set the top equal to 0, but I can go ahead and set the bottom equal to 0, and what will that give me? Yeah. Is that 1/2? So 1/2 will give me a vertical asymptote. That's one of the things I'm going to need to check. I'll even write that as a vertical asymptote, so I remember not to put a bracket on it. Now I need to find what x value is going to make this equal. So I'm going to check it. X plus 4 over 2x minus 1 equals 3. Multiply. X plus 4 equals 6x minus 3. Subtract, subtract. And you get 5x equals 7. Divide 7/5. That's the other thing you need to check. That's where they equal. That's where it's going to potentially start being false or true on either side. And then I have my number line again. 1/2, 7/5. This one will get a bracket, you need to remember that. So I try 0. That'll be 4 over negative 1, so negative 4. Is that less than 3? Yes. I'll try a number between them, like 1. That'll be 5 over 1. Is 5 less than 3? No. Try a number greater than this, like 2. So that'll give me 6 over 3, which will be 2. Is 2 less than or equal to 3? Yes. So check X check. So less than 1/2, greater than 7/5, with a bracket on the 7/5 only. That was if there wasn't a pesky number over here with a denominator. When we plugged in negative 5, you mean like if we were to plug it back into the equation? If you plugged in negative 5, what was it, this one? Was it this one? What would you get? You'd get negative 4 over negative 2, which is what? 2. So just like the last ones where we were finding where 0, you found where it equals, which is good. And this new problem? Same exact place. We solved it, got 7/5, and that again was what's going to make this equal and therefore potentially cause it to cross. Oh, I just subtracted x from both sides and then added 3 to both sides. And that gave me 5x equals 7. Yeah. Divided by 5 at this point. Yeah. If it makes more sense to you, that's why I like to always, you can subtract the 3 over. You're more than welcome to do that. It just changes the element of your problem. In fact, has everybody written down the stuff in the top right hand corner? Yeah. Oh, I used 0, I think. Yeah. Now, look at this. If what's throwing you off is why are you setting it equal, you can put everything on one side just like we did on the last one. If we had done that, minus 3, right, because I moved it over. Now, I need a common denominator, so I would multiply this by 2x minus 1 over 2x minus 1, giving me x plus 4 minus 6x minus 3 all over 2x minus 1 is less than or equal to 0. You could have done that. Now, you still, and if you did that, that's fine. So now what are you looking for? You're looking for what makes the bottom equal 0, 1/2, and what makes the top equal 0. What's going to make the top equal to 0? You set the whole thing equal to 0. That's negative 5x plus 7 equals 0. Subtract, divide, and you still get 7/5. So if it makes more sense to you to keep comparing it to 0, then by all means do that. Just the algebra is a little harder. Okay, here's your assignment.